Alright, here's the Chapter 8 test video. I thought I had this up, but I guess I didn't. So, first of all, what is this one? It says there's a 20% chance. Doesn't say that it changes. There's not a limited number of fish, and so, it seems like anyway. So, we have a probability of success of 0.2, and we're going to try our luck at 15. So this is looking much like a binomial. And I could get the distribution of binomial, and I'll show you a nice little trick on this. Second distribution, second distribution, go down to binomial and PDF. And if we put in that we have a 15 trials, comma, 0.2 chances of success, comma, and then I normally put in 0 and figure out the probability of catching none. Put in 1 and catching 1, but I can also go back here and just delete that comma and put parenthesis, and it'll give me the complete probability distribution. The probability of catching 0 is, oh, I got something in here. Something was strange. I got stuff in here. Okay, so let's do this again. There we go. 0.0352 if I wanted to keep 4 decimal digits. Then I go to the next one. It's 0.1319 if I kept 4 decimal places. This is for catching 0, for catching 1. And I could continue on doing this. 2 is 0.2309, and 3 is 0.2501, 4 is 0.1876, 5 is 0.1032, 6 is 0.42992. I don't need that, and so on. I could continue on with this. Whoop. 0.04, and they're getting smaller and smaller, and well, I could go all the way up to 15. But since this is binomial, what's the chances I get exactly 4 is this answer. So there's A. Chances of getting exactly 4 is 18.76%, or probability of 1.876. B. What's the probability to catch more than 4? That would be all of these added up. But all of them add up to 1, so I could just take these and subtract it from 1. Now I can add those up, but the calculator adds them up, as does the distribution worksheet on binomials. So if I pull that sheet out, I'm getting that right now, for 15 trials, where did it go? Where did it go? There it is. 15 trials. That's on this page. 15 trials with a probability of success of 20%, 2.2. The first 4 added up is 0.836. 0.836, and so for B, the answer would be 1 minus 0.836, which is 0.164. Now I could also do that on the calculator. 1 minus, add up. So now I'm going to do binomial cumulative, add up with 15 trials, comma, 0.2 success, comma, add up through 4, and I get, that's what the cum does, I get 0.1642, which is close enough. And then C, what is the mean? The mean, I could take that times that, plus that times that, plus that times that, do all 15 of them, which would take very long, but since it's binomial, the mean is simply n times p, which is 0.2 times 15, which is 3. 0.2 times 15, 3. That's the mean. And what's the variance? The variance I could get by taking that squared times this, plus that squared times this, plus that squared times this, plus that squared times this, all the way through them, then subtract the mean squared. But since it's a binomial, the variance is NPQ, which is going to be the N15 times P, which is 0.2, times Q, which is the opposite of P, which is 8. It's 1 minus P. And that turns out to be 3 times 0.8, which is 2.4. So if you use the calculator or the table, you didn't have to do these. This first one, A, was exactly 4. I would have done probability 2 here. I would have did all the way up to 4 minus all the way up to 3. I would have taken 8.36 minus 6.48 and got the answer for A. Or right here. A is 0.1876 or 1.188. So that's number 1. Number 2, find a math class. You're going to create a game of your own. So you're going to have players pay $2. They're going to flip. For some reason, people are having a hard time with this. Flip 3 coins. So the coin could either be heads or tails for the first coin, and heads, tails, and then heads, tails, heads, tails, heads, tails, heads, tails. The probability for each coin is 0.5. It doesn't change. It's heads or tails, so there's only 2 outcomes. That's a binomial. You could work this out. The outcome, since they're paying according to how many heads they show, it could be no heads, 1 head, 2 heads, or 3 heads. And the probability of these are 3 heads is 0.5 times 0.5 times 0.5 is 0.125. 3 tails is, which is no heads, is 0.125. And this is no heads. This is 1 head, 1 head, 2 heads, 1 head, 2 heads, 2 heads, 3. So there's 3 of these paths that have 1, and each path is 0.5 times 0.5 times 0.5. So we'd have 0.375. 3 times 125. 0.375, and there's the probability distribution. But we would have gotten those same numbers from the table with 3 trials, but we don't have 3 trials here. We could have also gotten it from the binomial distribution, second distribution, and I could get PDF with a 3 trials, comma, with a 0.5 success. And if I don't put anything, it'll give me all 4 of them. 0.125, 0.375, 0.375, and 0.125. There's the distribution. But since this was binomial, I didn't even need this. Now I could take this times this, plus this times this, plus this times this, plus this times this, add them up, and I would get 1.5. Let's do that. 0 times that's nothing. That's going to be 0.375 plus 2 times 0.375 plus 3 times 1.25 did I do wrong? 0.375. 0.375 times 2 plus, oh, 3 times, I did 1 point. Oop, I need to go back here and change it. It's 0.125. 0.125. There's what it comes out, 1.5. And I knew it had to be that because since this is binomial, the mean is n, 3 trials, probability of success 0.5, 3 times 0.5 is 0.15. And since these are the amount of dollars won by the player is going to win $1.50 on average. The average, the mean. But they have to pay $2. On average, so this turns out to be not fair. Fair means that the amount they pay and the amount they win should be the same. They don't expect to win any money or lose any money. They're expecting to lose 50 cents per play. To make it fair, the game should charge $1.50 to play, not $2. Fair, charge $1.50 to play. Okay. 3. The amount of time CWU spent studying has a mean of 4 hours. Now, that's kind of the average, but they could study anywhere above or below that. So this is not binomial. This is not anywhere above or below. It's going to kind of be a distribution that looks normal looking, where 4 is the middle. So now we're talking about a normal distribution. A standard deviation of 0.5, so here's 4.5 and 5 and 3.5 and 3 and so on. What's the probability that a randomly picked student will be studying more than 5? That would be up here. Now if we use the table, it measures from the middle out to someplace. And each standard deviation is one z-score. Here's z0, 1, and 2. So we'd be doing, we don't want these first 2 of the half. So all of this would be 50%, or half of the probability. And I want to get rid of these first 2. Now you should have in your notes that this is 0.3413. 0.1359, but they're also right on the table for z-score of 1, 0.3413. And if you go clear out to 2, you get 0.4772. That's what these first 2 add up to be, 0.4772. And so we want more than 5 hours, so that would be what's left. So 5 minus 0.4772, half minus that is 0.0228. There's a 2% chance that they study more than 5 hours per day. What is the probability that the student studies between 3 and 4? That's these 2 sections, which is the same as these 2 sections. So you can look up a z-score 2 on the table. You could also do it on here. Let's show how that would happen. Normal, add up between, 1 second, 3 and 4. The 3, 3, 4, with a mean of 4, and a standard deviation of 0.5, and we get 0.4772. So that's B, 0.4772. C, what's the probability a student studies less than 3.25? That's in between. That would be a z-score. See that? This is -1, this is -2. This is halfway between. It's -1.5. You can calculate it using the formula. Z is the raw score, which I said 3.25, minus the mean over the standard deviation. And 3.25 minus 4 is minus 0.75 divided by 0.5 is minus 1.5. You can check that on your calculator. Now, if you look minus 1.5, not minus, you can't look up minus, 1.5, you get 4,332. That would be how much area is here. And we want to say less than that, so we want this area, so that's a half, minus the 0.4332, which is 0.0668. That's C, and then D. Oh, and you could do that also on the calculator. We want to do from way down low here, so I'll just say 0 hour study, up to 3.25 hours studied, comma, with a mean of 4, comma, and a standard deviation of 0.5, close parenthesis, and it tells me 0.0668. Now, a minimum 25%. So that would mean top 25%. What is the amount of hours they study? So out here somewhere is 25% up here that they study. We want to know the hours, the raw score here. Which, if that's 25, between the middle and there is 25, and I could look up 0.25 on the table, and now I want the area to be 0.25, which is somewhere around 0.67 or 0.68. So the z-score would be 0.68, which is a raw score that I want to find, minus 4 over the standard deviation, multiply by 0.5 times 0.5, and then add 4. And oh, by the way, this would be yeah, this is right, and I get 4.34. Now I could also get this with the calculator. We're doing we know the area, and so we want to find the raw score, so that's inverse normal, where we want, now this calculator calculates area this way from the left side up, and so if I want 25% up there, I need 75% down there, so I'm going to go 0.75, and if I do that, it would have given me the z-score, 0.674 instead of 68. But if I want to get the raw score directly, I can do the same thing, but put in the mean 4, comma, and the standard deviation, and it'll tell me 0.433. 434. All right, I'll do 4 in just a sec.